Periodic classification of elements. Introduction to periodic classification of elements. At the end of this session, you will be able to understand about Introduction to periodic classification of elements, periodic classification of elements into blocks, periodic classification of elements into groups, periodic classification of elements into periods, and periodic tables. Before getting into classification of elements, let us recollect in brief about what are electron, proton, neutron, nucleus, electronic configuration, atom and element. Electron. An electron is a negatively charged component of an atom. Proton. A proton is a subatomic particle, found in the nucleus of every atom with positive electric charge. Neutron. A neutron is a subatomic particle contained in the atomic nucleus. It has no net electric charge, unlike protons consists of positive electric charge. Nucleus. The nucleus is at the center of the atom, and contains protons and neutrons. Protons and neutrons are collectively known as nucleons. Electronic configuration. The arrangement of electrons in an atom is called electronic configuration. Atom. An atom is the defining structure of an element, which cannot be broken down further. A typical atom consists of nucleus with protons and neutrons, with electrons circling around the nucleus. Element. It is a substance that cannot be broken down by any chemical reaction. For example, hydrogen, helium, carbon, oxygen, etc. Let us start with our current topic, periodic classification of elements. The arrangement of elements into different groups on the basis of their similarities and properties is called classification of elements. Periodic classification table. The arrangement of elements into periods and groups on the basis of their electronic configuration is known as the periodic classification table. Why it is necessary to create a periodic table? By arranging the elements in a periodic table, it makes it much easier to see patterns and trends in the properties of the elements. For instance, all of the elements in each column of the periodic table have similar properties, because of their electron configurations. Using the periodic table, we can predict the accurate properties of an element which you've never even seen. Let's discuss in brief about periodic classification of blocks. The periodic table of elements consists of 114 elements as on year 2006. Based on their properties, these elements are classified into 4 blocks. The 4 blocks are S block, P block, D block, and F block. The S block elements consists of alkali metals and alkaline earth metals. The P block elements consists of halogens. The D block elements consists of transition metals. The F block elements consists of lanthanides and actinides. Let's discuss about each block in detail. Elements consisting solely of S and P electrons in the outer shells are classified as S and P block elements. S block elements. S block elements are alkali metals and alkaline earth metals. Alkali metals. All these elements are metals, react with water to form alkalis and hydrogen gas, and one valency electron. For example, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Alkaline earth metals. All these are metals. Oxides of all of them are alkaline in nature, and have 2 valency electrons. For example, berkelium, magnesium, calcium, strontium, barium, radium. P block elements. P block comprises of metals, nonmetals, metalloids, halogens, and noble gases. The P block elements consists of group 13, group 14, group 15, group 16, group 17 and group 18 with more than one oxidation state. Metals. They are usually solids, strong and hard at room temperature. For example, aluminium, gallium, indium, thallium. Nonmetals can be solids, example, sulfur, liquids, example, bromine, or gases, example, oxygen at room temperature. Metalloids, elements that possess the characteristics between metals and non-metals. For example, they are generally semiconductors, that is, a good conductor when compared with non-metals, but a poor conductor when compared with metals. Example: boron, silicon, germanium, etc. Halogens. The halogens elements are non-metals. These elements react with water to form acids, and it is having one valency electron. Example: chlorine, bromine, iodine, etc. D-block elements. The D block consists of transition metals. These elements give off electrons from their outer s orbital, but most can lose a multiple number of d orbital electrons, for example, copper, which has two common oxidation states +1 and +2. Transition metals. Any of the metallic elements within groups 3 to 12 in the periodic table, that have an incomplete inner electron shell, and that serve as transitional links between the most and the least electropositive in a series of elements. They are characterized by multiple valences, colored compounds, and the ability to form stable complex ions, is called transition metal. F-block elements. In lanthanides and actinides, 4 f orbitals and 5 f orbitals are filled respectively. So, these elements are placed in F-block. Or, lanthanides and actinides are called F-block elements, because last electron in them enters into f orbitals of the antipenultimate, that is, inner to penultimate, shell, partly but incompletely filled in their elementary or ionic states. Now let us move on to classification of groups and periods. The vertical arrangement of element, or vertical columns, down the periodic table are called groups. The elements in these groups have the same number of electrons in the outermost shells, the valence shell. Elements with same chemical properties are placed in same vertical column or group. Elements in the periodic table are arranged into 18 groups and 7 periods. The 18 groups in the periodic table are: the group 1 elements are called alkali metals. The group 2 elements are called alkaline earth metals. The group 3 to group 12 elements are called transitional metals. The group 13 elements are boron, aluminium, gallium, indium, thallium. The group 14 elements are carbon, silicon, germanium, tin, lead. The group 15 elements are called nicogens or nitrogens. The group 16 elements are called chalcogens or oxygen. The group 17 elements are called halogens. The group 18 elements are called noble gases. The horizontal rows in the periodic table are called periods. The elements in these periods have the same number of valence shells. There are 7 periods in the standard form of the periodic table, that is period 1, period 2, period 3, period 4, period 5, period 6, and period 7. Periodic classification of elements are divided into 7 periods and 18 groups. Here, image showing the modern periodic table with period numbers in group. The lanthanide series and actinide series are also displayed here. In general terms, definition of group is, columns of elements are called groups. In general terms, definition of period is, rows of elements are called periods.